that are marked out in special literature. Then there will be a little note about theories that are proposed to be explanations of this phenomenon. Then we will watch the video and analyze it. And finally, I will make a little conclusion. Ball lightning is an unexplained atmospheric phenomenon. It's usually associated with thunderstorms, although it lasts considerably longer than a street lightning. Let's find out what characteristics ball lightning has. Size. It's usually from 5 to 13 centimeters in diameter. The average diameter is 24 centimeters. It's hardly changed during the observed lifetime. Temperature. We still don't know the true temperature of ball lightning, so we just have some suppositions of it. In different theories, it's changed from 500-700 Kelvin to 14,000 degrees centigrade. Color. Color varies from red to violet. In other words, it can be any color of the visible spectrum. It's interesting that it doesn't correlate with size and any other properties of ball lightning. Maybe it depends on impurities. The most common color is plain black. Dynamics. Ball lightning usually flies horizontally above the ground at speeds from 0.1 to 10 meters per second. There are also reports of vertical types of motion and more regular types. If a ball lightning is in the room, it usually flies along the walls. Also, it can penetrate through tiny holes and cracks. They can see ball lightning. Now let's talk about theories. They are very different, although most of them are frames of plasma physics. There is such a big variety of them because none of them can explain all of the properties of ball lightning. One of the differences between these models is connected with the problem of energy. Is the external or internal source of energy. Also, there is a division that is connected with inner-side structure of a ball lightning. Different research mark out different layers, suppose different shapes. Now, when we know a little about ball lightning, let's watch the video. conditions suggests a probable ball lightning. There you can see conceptual positions of the ball in this view, and velocity analysis of it led to this graph of speed. We can say that it is also typical to ball lightning. The attributes are in agreement with the electrical model of Turner that says that there is a particle plasma that is surrounded by shells at low temperature where ion combination processes and hydration take place. The observed relatively short duration of the ball doesn't require the assumption of any external